Welcome to The Explainer. If you're a focused learner looking to completely master the Cambridge Computer Science syllabus, you are in exactly the right place today. We are diving into an absolute masterclass that we like to call the MasterChef Computer Science Exam Strategy. Seriously, I want you to start thinking of answering your exam questions exactly like preparing a Michelin star meal. To pull it off, we need a flawless recipe for success. In this scenario, your raw evidence and data from the exam paper, those are your ingredients. Your analysis, the way you process that data, is the actual cooking. And finally, your evaluation is the plating. It's that beautiful, pristine final presentation that examiners literally cannot help but award top marks to. Specifically today, we are targeting a notoriously tricky area in the 9618 syllabus, relational database features addressing file-based limitations. And look, whether you're studying syllabus code 0417, 0478, 0983, 0984, 2210, or studying the advanced 9618 papers, mastering this conceptual shift from flat files to relational models is absolutely critical for your grade. Let's look at a real Cambridge Computer Science past paper question, specifically from paper code 9713, to set our baseline. The question asks candidates to evaluate how a relational database overcomes the limitations of a flat file approach for a growing medical clinic. Okay, let's dive into this insider's guide and unlock your maximum mark potential. Take a look at this direct quote from a senior examiner. It reveals something incredibly fascinating. They state explicitly that this topic is one of the most misunderstood areas in all of computer science. So right off the bat, if you've struggled with this, take a deep breath because you are absolutely not alone. To really understand why this happens, let me introduce you to two typical students we see literally every single year. Let's call them Alex and Sam. Alex is what I like to call a walking encyclopedia. When faced with that medical clinic database question, Alex just overloads the page with raw computer science facts. We're talking massive paragraphs listing primary keys, foreign keys, data redundancy, and normalization. But here's the fatal flaw. Alex completely forgets to analyze how or why those features actually address the limitations of the flat files. There's zero cooking happening here, folks. It's just a pile of raw ingredients dumped on the examiner's desk. And then we have Sam. Sam's problem is different. Sam is racing against the clock, rushing through the exam, and completely missing the command word requirements in the prompt. Sam writes down some correct things, but the answer is totally disorganized and entirely misses the core assessment objectives the examiner is actually grading against. If you look at their mock papers, you can practically see the red pen marks bleeding all over the page. Today, we are going to show you the exact strategy examiners are desperately looking for, so you can turn those red marks into green check marks. To get there, we need a highly structured roadmap. Here is exactly what we're going to cover in this exam strategy masterclass. First, we'll unpack the database dilemma to clear up the foundational terminology. Second, we're going to look at the core theoretical principles to show you exactly how marks are distributed based on analytical depth. Third, we'll reveal the procedural framework. This is your step-by-step recipe for flawless execution. Fourth, we'll explore the critical analysis techniques you need to elevate your answers to the A-star tier. And finally, we'll go through the top examiner warnings to keep you out of the traps that catch 90% of students. All right, let's jump straight into our first major hurdle, the database dilemma, and how to avoid the terminology confusion that ruins so many answers before they even begin. Before we can ever solve the dilemma, we have to define it correctly. When discussing the transition from file-based systems to relational databases, candidates constantly trip over their own words. They use the word file when they actually mean table, or they say record when they should be saying tuple or row. Now, remember that a legacy file-based system suffers from something called data dependence. That means the program and the data are so tightly coupled that changing one breaks the other. It also suffers from massive data redundancy. Imagine the same patient's address being stored in 5 different text files across a clinic. That leads to severe update anomalies. If they move, you have to update it 5 times, and if you miss one, your data is corrupted. If you don't clearly articulate this exact dilemma first, your explanation of the relational database solution is going to fall totally flat. So, here is your urgent examiner alert. Candidates must always define key terminology explicitly before using it in extended responses. It is non-negotiable. To do this perfectly, you have to decode the command words in the question, words like evaluate, compare, or explain, and apply what we call the PEAL framework. That stands for point, evidence, explanation, and link. You make your point by clearly defining the term. You provide evidence straight from the scenario given in the paper. You explain how the relational database feature, like a foreign key establishing referential integrity, solves that specific file-based limitation. And finally, you link your conclusion back to the prompt. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's move into section 2, where we take that Peel framework and apply it to our core theoretical principles to achieve true analytical depth. The theoretical architecture of relational databases doesn't just rely on knowing the words. It rests on precise definitions, mapping out causal relationships, and integrating concepts with other syllabus areas. You aren't just regurgitating a glossary. You are proving to the examiner that you understand how a complex system breathes and interacts. When you write that normalization reduces data redundancy, you have to trace the causal relationship all the way through. Less redundancy means fewer update anomalies, which directly ensures data consistency across the entire database management system. Let's look at the transformation between our two students. On the left, we have superficial breadth. This is Alex's old method, throwing every single buzzword at the paper hoping something sticks. Listing security, redundancy, data independence with absolutely no context, that loses marks instantly. On the right, we have analytical depth. This is the computer science success blueprint in action. This is where you actively gain marks by building causal chains. For instance, principal examiner reports tell us that candidates who make cross-topic connections, like linking database security features directly to encryption standards and access rights from earlier in the syllabus, achieve significantly higher grades. Imagine Alex and Sam applying the Peel framework right now. Alex stops listing and starts explaining why the primary key matters. Sam stops rushing and specifically links the answer back to the medical clinic's data privacy needs. Suddenly, we go from zero analysis to Michelin star plating, and those red marks transform into green check marks right before our eyes. So how do we guarantee you do this every time? Let's move to section 3, the procedural framework and the incredible power of the method mark strategy. Knowing the theory is just having a fully stocked pantry. The procedural framework is your actual real-time cooking technique in the exam hall. This is where we leverage the method mark strategy. Look, in complex, multi-part database questions, examiners are actively looking to award points for your process, not just your final answer. If you can demonstrate a structured methodology for identifying entities and relationships, even if your final entity relationship diagram has a minor flaw, you can still secure the vast majority of the marks. Here's the exact 5-step procedural framework you need. Step 1. Deconstruct the question. Actually take your pen, circle the command words, and identify the core task. Step 2. Extract data. Pull only the relevant entities and attributes from the scenario text. Step 3. Select framework. Ask yourself, do I need an ER diagram here, a normalization walkthrough, or an SQL query? Step 4. Execute with clear standard notation. Step 5. Present with precise terminology. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Implementing these 5 steps brings an insane amount of clarity. If you were handed a past paper right this second, could you execute these 5 steps in the first 60 seconds? That is the exact speed and confidence this blueprint provides. Now, this secondary sequence applies specifically to the algorithmic thinking required when evaluating file-based limitations. It's step-by-step decomposition, data structure selection, efficient code implementation, and rigorous testing. This brings us perfectly to our interactive workshop. We're going to do 3 rapid-fire challenges to test your skills. I'm putting 60 seconds on the clock in our minds. For challenge 1, the data scan. I want you to mentally picture a massive, complex data table given to you in an exam. A classic, unnormalized flat file for a massive retail store. There are repeating groups of data everywhere. Customer names are duplicated on every single order line. Look at that data source. Your challenge is to extract the core trend. What is the absolute biggest limitation staring you in the face? 10 seconds left, and time's up. If you said data redundancy leading to a massive risk of insertion and deletion anomalies, your analytical cooking is perfectly on point. Let's keep this momentum going and shift focus to Section 4, Critical Analysis Techniques and Higher Order Objectives. These critical analysis techniques are the final plating of our MasterChef dish. These are the higher-order assessment objectives that truly separate average answers from the elite top-tier grades. So let's jump into Challenge 2. Find the flaw. I'm going to read a flawed sample paragraph, and I want you to pinpoint exactly which sentence is bleeding marks. Listen closely. A relational database is better than a file-based system because it uses tables, which makes finding data faster, and it has primary keys. Okay, did you spot the flaw? The entire middle section lacks technical specificity and completely fails to evaluate the alternative. Saying it makes finding data faster is way too vague for Cambridge. An examiner wants to see you explain that a database management system utilizes dedicated indexing and structured query languages to optimize data retrieval, completely eliminating the sequential search limitations that cripple traditional flat files. To avoid these simplistic flaws, you have to internalize the deconstruct, solve, evaluate model. Identify the given information, break it into logical steps, solve it systematically, check your logic for reasonableness, and make justified recommendations. Let's lock this in with Challenge 3, speed writing. You have 30 seconds. Mentally construct one perfect Peel paragraph explaining how data independence is achieved. Ready? Go. Your point: relational databases achieve logical data independence. Your evidence: the DBMS explicitly separates the data definition from the application program. Your explanation: unlike legacy file-based systems where any minor change to a file structure requires entirely rewriting the software, database relations can be altered without breaking the front-end application. Your link: therefore, relational databases ensure long-term scalability for the organization. Boom. That is how you use the model to score full marks in record time.
A massive element of that evaluate stage is comparative analysis. You can't just list features in isolation. True comparative analysis requires addressing both similarities and differences. And to get the marks, you must use comparative connectives. I'm talking about words like whereas, conversely, or in contrast. Please don't just write, files have data redundancy, databases have normalization. That's disjointed. Instead, write, file-based systems suffer from inherent data redundancy due to isolated data silos, whereas relational databases utilize normalization to ensure data is stored only once, thereby preserving ultimate data integrity. Do you hear the difference there? You are supporting each side of the comparison with direct evidence to draw a firm conclusion about its relative importance. This is plating your answer so beautifully, so professionally, that the examiner literally has no choice but to award you the maximum marks available. Let's move into our final and perhaps most crucial section, Section 5. Top examiner warnings and how to bulletproof your answers. We've built the perfect MasterChef strategy, but now we need to look at the ultimate pitfalls straight from the principal examiner reports. These are the landmines that trap even the best prepared students. These mistakes will completely destroy your beautifully plated response if you aren't vigilant. Here are the top 3 mistakes you must avoid at all costs. Mistake 1, vague answers, lacking specific technical details. Remember our faster finding example? Always use precise, syllabus-approved terminology. Mistake 2, forgetting boundary conditions in edge cases. When discussing referential integrity, top students always mention the edge cases, like what exactly happens if a user attempts to delete a primary key record that is currently linked to an active foreign key. That level of edge case analysis demonstrates true mastery. Mistake 3, answers not applied to the specific context. If the past paper is about a hospital database, your examples must be about doctors, wards, and patients, not generic customers and retail orders. Apply the context. To recap our complete system, remember the 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, strict Peel framework application. And number 3, a time management matrix so you spend the exact right amount of time planning before your pen ever hits the paper. So the ultimate question is, are you ready to apply the deconstruct, solve, evaluate model to your very next past paper? The difference between an average grade and top marks lies entirely in how you plate your knowledge. The raw ingredients are sitting right in front of you. How will you cook your next exam? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.